And then delta T for copper. It's going to end at some unknown temperature. We're not sure what yet, but it began at 120. So that's the copper side done. We plugged in everything that we do know. The one thing we don't know is TF, but that is what we want. Is that a question? That's fine. When you become a teacher, suddenly anything that looks like a hand is just immediately out of the corner of my eye. Yes? Okay, so then on the water side, again, what's the mass of 1 liter of water? Very good. And then the specific heat capacity of water is
4,186.
very good. And delta T of water. We don't know its final temperature, but we do know its starting temperature is 21 Celsius. So, what we know is the mass of both objects, the C of both objects, the initial temperature of both objects. We don't know the final temperature of either object, but conveniently, what do you think the final temperature of the two objects is going to be in relationship to each other? The same. They're both touching each other. They are part of the same system. Thermal energy is going to keep leaving the copper and entering the water until everything's at the same temperature, at which point we've reached thermal equilibrium. So the whole point is that the two TFs are the same thing. They are a thermal system in thermal contact. They will try to reach thermal equilibrium. So it's the same TF. We just need to get all the TFs together and solve for what they're able to. So it's in two separate places, but it's our one remaining variable. We can solve what we have here. Now, do you guys want me to do the algebra one step at a time? Okay, if at least one person wants it, that's what I will do. So, I don't need to get my calculator back out to be able to do the algebra one step at a time. So, what do you think our first step should be to get those TFs out from buried inside of that mountain of parentheses?
Multiply and distribute.
Okay, so each of these TFs are inside of parentheses with something being subtracted from it, and then that whole term has things multiplied by it. So to get rid of these parentheses, the first thing we have to do is factor these numbers inside. So distribute, very good. First thing though, these two numbers are both being multiplied in, so let's figure out what these two numbers are when you multiply them together. So 0.05 times 387. Keep our negative sign out front. That's going to be negative 19.35 times TF minus 120 equals, well, what's this one going to be? Yeah, the one's kind of pointless. So we can just basically, when we multiply the one in, that changes nothing. So the right side is virtually unchanged. But now we can distribute those constants inside of the parentheses. So negative 19.35 times TF is negative 19.35 times TF. Then negative 19.35 times negative 120 gives us positive 2322. So that's the left side distributed. Is the table cutting off anyone's view of this? Or my marker rainbow? Okay. So now we distribute this inside. 4,000 and change times TF gives you 4,186 TF. Then 4,186 times negative 21 is a negative 87,927. So we've got a lot of big numbers we're dealing with, but we've got the TFs out of parentheses. We can now manipulate them and move them between
I got
sides.
87,506.
Yeah.
Oh yeah, sorry. Even if you have a degree in this, you make mistakes sometimes. I put a 7 into my calculator instead of a 6. So, thank you all. If I ever do make a mistake, please tell me, because I'd rather feel silly and fix it than do something wrong and then you guys don't learn it right. So, the TFs are free. Now we just have to swap them between sides. When I look at this, my instinct is I see this number's negative, this one's positive, this one's positive, this one is negative. So if we add if we add positive 19.35 TF to both sides, that cancels it over here and sends a positive number over here. Conversely, we can then add positive 87,906 to both sides. That gets rid of it over here and makes it a positive over there. So if I was to kind of do that all at once, we would have 2322 plus 87,906 equals 4,186 TF plus 19.35 TF. Does everyone see how we got from one to the other? Is that one step okay? Keep backing into this thing. I'm not used to it being here. Surprising good backtrack. Okay, so add these together, just addition. That should give us positive, again, we're in the positives now, 90,228. Does anyone disagree? Okay, then add these together. Notice these are just, oh no, zoom tight. So both of these are mass times C. Notice the term we got from the water is much, much bigger than the term we got from the copper. So 4186 plus 19.35, 4,205.35 times TF. So now to free the TF, we just have to divide both sides by this term. So our temperature final is 90,228 over 4,205.35. Line is my 5, look like a fish hook. There we go. And that will give us one solid final number, which is approximately
21.46.
very good, 21.46.
That's hardly anything.
That is hardly anything. What are our final units? Very good, degrees Celsius. And now, for the copper, from the copper's perspective, we've cooled down by about 100 Celsius, which is pretty dramatic. For the water, though, we've only warmed up by not even half a degree. And that's, again, due entirely to their different C constants. And again, it's a pain when you're trying to heat up water to make spaghetti or something, but it's really useful for using water as coolant. Because 1 unit of water can take a lot of thermal energy before it starts getting hot. So a lot of cars use water as coolant. So the water absorbs thermal energy from your engine and then distributes it elsewhere in the vehicle so that your engine's not overheating. And again, this is the kind of thing blacksmiths do on a regular basis. They heat up the metal to where they can work it at several hundreds of degrees. Then you dunk it in water. That cools the metal immediately from like 500 down to room temperature, but the water only goes up a couple degrees. So, We also use it in nuclear power plants to absorb all the heat being given off by the radioactive materials. So, again, water's useful properties are convenient for us 99.9% of the time. Any questions on basic calorimetry is what we call this. Alright, so again, login website. There's now 2 homework sets posted, but they are staggered a little bit in terms of their due date. Do work on 10 first. You have time after that to do 11. Always do your homework before you do the quiz. Quiz should be the last thing you do because the homework helps you practice your quiz. That said, neither is a huge part of your grade, so do not panic about either of them, but do it. It's practice for your test. And we do have lab this week. Don't worry though, it does involve boiling water, so be careful and bring closed-toed shoes, but don't worry, it'll be interesting. So, come to lab, again, closed-toed shoes, there will be hot water involved, and have a wonderful day. And I just turn on the phone before, my battery fills up.
Where are the other?
Always fills up.